Our next speaker is a professor at the Electrical and Electronics Engineering Institute at the UP College of Engineering and is now the acting director of DOST's Advanced Science and Technology Institute. Friends, let's give a warm welcome to Dr. Joel Joseph S. Marshall.
I was asked to talk about infrastructure buildup. Now, let me share with you that when I was thinking about this infrastructure, probably in our minds means physical infrastructure, but there are various components of this in relation to space technology, and I hope to share this message through my presentation. Okay, I'm going in particular talking about data, industry, environment, and crucially, people. Good afternoon to our dear secretary, the other secretaries of DOST, and Yusef Dennis from DICT, friends from the academy, fellow workers in government, media people, partners in industry. Okay. First, a perspective. This is something I always like to start off with in this presentation about space technology, especially when people are wondering, what are we doing as a country whenever when we talk about space? Why are we going into space technology? I'd like to take a step back and talk about, well, computers. Let's look at the history of computing, shall we? We are familiar with desktop computers, the computer rooms. We use them all the time. Of course, you still see here old pictures of CRT monitors, since replaced by LCDs, LEDs. Then, with the advent of the internet, we put computers in far places, centralized them into so-called data centers. So they're now in the so-called cloud. And we talk about cloud computing because figuratively, we don't know where the data centers are, actually, so figuratively, we think of a cloud, and that's where the computing happens. When we do computing, we don't necessarily have to be doing fancy stuff, like simulations, computer-aided design. When we send out a tweet, update a Facebook status, we are computing, we're contributing to this ecosystem of computing where there is computational load being, processed by some computer in some far-off cloud or data center. So think about that. It's become more participatory, right? It's called social computing. Computers are changing. They're no longer laptops, desktops. They're in our pockets, in our wallets, in our wrists, on our wrists. Pretty soon in our clothes. They're becoming increasingly embedded in the environment. So we have to change the way we think of computers. And they say these computers will go the way of the light bulb. The analogy is with electricity. In the beginning, it was pretty exclusive, right? Remember the mainframe era, where we had to put these computers in one large room and it was serving many people. But they're going to disappear. We're going to take them for granted. Right now, when we don't get information, we complain. When we're not connected, or there's no Wi-Fi in a certain place, or fortunately here in this hall, the Wi-Fi is free, so we're thankful for that. But otherwise, when it's not there, we complain. We take things for granted. And so, this is something I always flash. According to Mark Weiser, the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they're indistinguishable from it. So computers are becoming increasingly embedded in the environment. They're vanishing. And so guess what else computers are vanishing into? Of course, this is a space forum, so we should think of space. And this is the Wata-1 being released into its orbit from the International Space Station. Right? Actual pictures taken by an astronaut, and this was almost 3 years ago, April 2016. Right? And really, inside that 50-kilogram box are at least 6 computers to control the payload, to control its orientation, to control its radios, to control its power supply. Many computers inside that box. Right? And one of the important things, of course, the main mission of the satellite is to do scientific Earth observation. So all the cameras that you see here are being controlled by a computer that tells it what to do, where to take the picture, what kind of picture to take, and where to point it. We take it for granted that this satellite is 400 kilometers up, and it has to point to an area like Metro Manila, and it has to do it accurately. Otherwise, you might take a picture of Cebu. when you're intending to take a picture of Metro Manila. So it's not that easy. Wow, time goes fast. Did the introduction include my time? Okay, let me speed up. The future is small because a lot of countries like the Philippines increase new entrants in space technologies are looking to small satellites as a beachhead strategy to meet scientific Earth observation, right, and capacity building and industrial build-up in a cost-effective manner. So, but I just mentioned we're launching satellites, but forget about that. We're not really doing that. That's not what we're here for. What are we doing? We're putting computers in orbit. Okay? So that's the perspective I wanted to share with everybody, and I'll take it wherever I go. Right? So the next question is, why are we doing that? Why are we putting computers in orbit? The answer is simply data. That's the first answer. Okay. Data that enables science-based policies and intervention. The satellites are up there, and from their strategic vantage point, they have a spatial temporal, we can obtain information at a spatial temporal resolution unheard of before. We should be participating in this kind of information and data generation mechanism. Otherwise, we will continue to suffer from information poverty. What kind of data? Satellite images like this. You see here actual pictures taken by Diwata-1, and in the last picture you see how much of the country we've covered. This was as of August last year. It's very challenging to cover the entire country because of the irregular orbit of this microsatellite, but we do our best. And oftentimes when we're trying to hit the spot, we're blessed with clouds, and so when the picture comes out, we see clouds. Right? There's a lot of work that to be done, right, in terms of really getting information. So it's not as straightforward as putting a satellite up there and we can get data. We have to put the right payloads in there, we have to have the right mission. Okay. And supporting these missions is, we talk about infrastructure, is ground infrastructure. We put assets up in space, we need to have its counterpart on Earth, and this is Pedro, the Philippine Earth Data Resource Observation Center, right, located in ASTI. We've since put a cover on that dish, and now it has a radome. And pretty soon, we will have one in Davao. You see that on the right, it's bigger. The one in ASTI in Quezon City is about 3 meters diameter. This is 7 meters, so it's much bigger. It's located right beside Davao Airport. Hopefully by July, we should have it operational. And these ground stations are used to obtain data and images, not just from Diwata 1 and 2, our microsatellites, but also from other satellites, commercial satellites, that complement the information and data we get from our own microsatellites. Okay. Now, all this data is combined with other sources of information. We do have sensors on the ground, weather stations, water level monitoring systems. All these sensors that have been developed through various DOST projects over the past decade. And we are performing what we call data integration and data fusion. That's very important because the source of information, actionable information, is not just from one source. You have to combine it to gain actionable intelligence. That all feeds in to our high-performance computer, and we can distribute that to our National Research Education Network, which ASTI also maintains. It's called PregiNet. Right? So through PregiNet, we can connect different academic and research institutions to this information, and they can access the supercomputer that is in ASTI to process this data. That's what this slide is about. Okay? Now, let me just give you another perspective here. In this data economy, it's very important to highlight this capability of generating data and processing it and turning it into actionable information. So this is the kind of work we did for Typhoon Mangkut or Ompong. We categorize, Pag-asa as a way of categorizing typhoons. We have our own category of typhoons. We call it Data Mobilization Index. Right? In other words, we categorize typhoons by the sheer amount of data we use to prepare for it and to respond to it. I think as a society, Philippine society, we need to have this in our conversation. We need to have data scientists and engineers in conversation. We talk about DRR because it's a capability we have invested a lot in, and we need to realize its full potential. So we, just for information, Ompong mobilized about 8 terabytes of data in satellite images. Okay. So it's this big data economy spurred by so-called new space companies. Right? So for industry here, and for the young guys in the audience, there's an opportunity to start your own company, just leveraging on the information overload or the data overload that's present to all these satellites orbiting the planet. You think about this, there are companies that are counting the number of cars in a parking lot, coming up with an algorithm to predict the profitability of a retailer. There are these various applications from satellite images beyond disaster risk reduction and management. Okay. Promise to speed up here. Now, talk about data, but it's not just about the data, it's also about building an industrial base. You will hear more about this from our colleagues in the program in talks after this. These are blocks that were built, designed in our local laboratories that now have space heritage. That means they're actually on board an orbiting satellite and they are surviving the rigors of space. And to make this happen, we had to talk to industry. We had to talk to fabricators, to manufacturers based here in the country. We want to take this partnership further. In other words, in plain speak, we don't want to treat our industry peers as suppliers or contractors. We want them to be partners in this endeavor, hoping to find a good connection that's mutually beneficial and is sustainable for the future of this kind of program. Okay. And we're also building an environment. This is laboratories that will house all the people that we've been training so far in building these satellites, academic laboratories, because they are feeders into industry. We have to generate the people, they have to be busy in the laboratories. You see here facilities, right? Researcher workstations. We give them a nice view. You see that? We need to have world-class spaces. And we're rethinking the way we build our laboratories in light of interdisciplinary research. We need to have open borders, we need to have open communication with researchers of different disciplines. This is a facility you'll probably hear more of from my colleagues' side. This is a full anechoic chamber for antenna testing. I know it's already generated some interest from our industry partners in electronics and wireless. You can use this facility perhaps starting April this year. Now, this is the last point I want to make. When we build satellites, we also build people. It's part of the infrastructure. And what kind of people are we trying to build? Here's the takeaway from this. It's so-called T-shaped people. And the message to industry is, do you really have to wait for somebody labeled as an aerospace engineer in order to do something in aerospace? No, because we're already training them. They are electrical, mechanical, materials, chemical engineers, remote sensing scientists, they are computer scientists, yet they're gaining a perspective across different systems, and they're branching out to different fields, and they are ready because they are trained to build really complex and reliable systems. So we don't really need to wait to have an aerospace engineer. We're trying to give this perspective to people in these traditional vertical disciplines, and they will have this branch across the different fields, and they work with colleagues in different areas to come up with a larger front by which they can attack bigger problems. Okay, so these are the different fields I was talking about. Right? That's part of the program. Now, one more thing before I end. Space technology requires stamina. Just looking at this slide and comparing ourselves to different countries in our regions, how they've been in this ball game longer than we have, that's why we call our program Stamina for Space. Because as a country, if we embark on the space technology program, we have to be in it for the medium to long haul. Because that's how impacts and outcomes are realized from space technology programs. We are addressing problems that are immediate, but we're also building for the future. With that, I want to thank everybody for their attention.